Hello everyone. In this video, we're going to be solving an interesting homemade differential equation. We have y prime divided by y double prime equals the square root of y. Y double prime is the second derivative of y, and y prime is the first derivative. So we need to find a function that satisfies this equation. We're also going to be taking a look at the results from Wolfram Alpha, if I don't forget. All right, let's get started. First, I'm going to go ahead and cross multiply this. So that gives me y prime equals y double prime multiplied by square root of y. Now, when you see something like this, you're probably thinking, wouldn't it be nice if we had the y double prime in the numerator? So we're going to go ahead and work on this, but let's save this for now and talk about what happens if we invert both sides. And we get something like this. Why do you think this form might be important? Because this kind of reminds me the ln of a function. Actually, the derivative of that. Because what's the derivative of ln u? Isn't it u prime over u if u is a function of x and we're differentiating with respect to x, then ln u, the derivative of ln u is going to be this one. Make sense? And when you look at something like this, it's the second derivative divided by the first derivative. So if I use substitution and set y prime equal to u, right, then from here I'm getting the same thing, u prime divided by u. The problem with this approach is, though, even though substitution is really cool, that we don't really have anything for y. So what are you going to name y if you call y prime u? Then is it going to be the integral of u dx? That's going to be, again, very, very problematic. So we're not going to be able to use this, even though it kind of looks like usable. We're going to do something else. Anyways, let's continue with this one. After cross multiplying, we got this relationship, y prime equals y double prime times the square root of y. Here's what we're going to do. We're going to divide both sides by square root of y and write this as y prime divided by square root of y equals y double prime. And I'll tell you why this is helpful y in a little bit, okay? Let's write y double prime on the left hand side, and on the right hand side I want to write this as y prime times 1 over square root of y. Make sense? Awesome. And then I want to do a little bit of hocus pocus here, which is multiplying both sides by 1/2. If you multiply both sides by 1/2, you're going to get this, and you're going to put a little 2 here. And you'll see why it's very helpful in a little bit. Now, here's the thing. The left-hand side, without the 1/2, it's basically the derivative of y prime, right? Because that's what the second derivative is. But with the 1/2, we can just put the constant in the front because we have a constant rule, right? And on the right-hand side, we have y prime and 1 over 2 square root of y. Now, if you think about what is, or 1 over 2 square root of x is the derivative of what function? In other words, I'm trying to integrate it, right? This would be the derivative of square root of x. But we have the square root of y. So in other words, what's the derivative of the square root of y? It will be 1 over 2 times the square root of y, just like this one, times the derivative of the inside. By chain rule, that will be y prime. Uh-oh, we got the exact same thing. In other words, the right-hand side is the derivative of the square root of y. Awesome. We got 2 derivatives, which means we can integrate. And again, 1/2 being a constant, nothing is going to happen to it. It's just going to stay there. So by integrating, we get the following. 1/2 times y prime. Integrating will basically take out the outer derivative. And on the right-hand side, we're going to get the square root of y, sorry. But there's going to be a plus constant. Make sense? Obvious, right? We should have a constant. So what do we get from here? So here's what happens. We can go ahead and isolate y prime. Let's multiply everything by 2. That's going to give us y prime equals 2 times the square root of y plus 2c or not 2c, right? And then from here, we do get the following. 2c is actually a constant, isn't it? So we can kind of replace it with something like k, maybe. K being a constant too. So let's go ahead and write it that way. And now I have a differential equation which is actually separable, right? So for a moment, we can go ahead and assume that k is equal to 0 for simplicity's sake. Make sense? Because something nice is going to happen if k is equal to 0. So for a moment, let's just assume k is 0. And that would happen if we were given any initial conditions, like y prime at 0 or something like that. Anyways, if k is equal to 0, then y prime equals 2 times the square root of y. And can you solve this? We can replace y prime with dy over dx. And then I can go ahead and write this as dy over 2 root y equals dx. You see, when you write it this way, it is not very clear. But when we separate the variables, because this is a separable differential equation, then things become more clear. Look at this. This is, again, the derivative of square root of y. So when we integrate, we get something nice, right? And what are we getting? We basically, by integrating both sides, we get square root of y on the left-hand side, and x plus another constant. We can call that c sub 1. Maybe we should have used that before. But anyways, you get the idea. Or maybe we can use something like c, what else can it be? I don't know. I can't really think of any constants right now. Maybe an a. Let's use a instead of a subscript. Let's use a. A is a real constant. And now, since we're trying to solve for y, let's go ahead and square both sides, right? And when we square both sides, we're going to get y equals x plus a quantity squared. Let's just remember that, okay? But we're going to expand. When we expand, we're going to get x squared plus 2ax plus a squared. Don't forget, a is a constant. So that looks like a solution, doesn't it? This is the solution to our differential equation. And now we're going to do something interesting, checking our work. What was the original equation? Y prime divided by y double prime equals square root of y. And then after this, I can go ahead and show you the result from Wolfram Alpha, which you are hoping to see the same thing, right? Or maybe with slight modifications. All right, so let's go ahead and plug it in. This is my function. You can use it either way. But y prime is just going to be 2x plus 2a because a is a constant. And then that's divided by the y double prime. Y double prime is the derivative of 2x plus 2a, which is just 2. And that gives us x plus a, which is the square root of y, because that's exactly what it is. Therefore, this equation solves the problem, or it's a solution to the original equation. Does that make sense? Okay, looks like it satisfies. And since we could only find one solution, we could only come up with a solution, it worked, and that's fine. But this is an oversimplification, well, sort of, because we assumed k equals 0. Now let's go ahead and take a look at what happens if k does not equal 0, and then we're going to look at the result from Wolfram Alpha. Okay, so let's go ahead and take it from here. Y prime is 2 square root of y plus k. Y prime is 2 square root of y plus k, k being non-zero, because we already know what happens if k is 0. And then we're going to do the same thing, separate the variables, and that's going to give us the following. dy over 2 root y plus k equals dx. And now we're going to integrate again. But this time, things aren't going to be that nice. It's not going to be super bad, but it's not going to be that nice either. So here's what we're going to do. Let's use substitution. I want to replace this with u maybe. So u equals 2 root y. I don't know what is happening. In some areas of this document, it's just not writing. U equals 2 root y plus k. And then our goal is to get to dy. So let's go ahead and isolate y. 2 root y is u minus k. Don't forget k is a constant, right? And now we're going to square both sides. 4y is equal to u minus k squared, or u squared minus 2ku plus k squared. And then we can divide both sides by 4 or just multiply by 1/4. And either way is fine because the constant is not going to matter. I mean, when you differentiate. That's why. And I do need to get to dy from here, right? So what is dy? dy is the derivative of this expression, which is going to be 2u, happy birthday to you if it's your birthday, minus the derivative of 2ku is just going to be 2k. K squared is a constant. I don't care about it. And I just divide by 4. And of course, don't forget to multiply by du because this function is in terms of u. And then if you divide, dy is going to be u minus k over 2 du. Awesome. We're going to plug this into our equation. And let's see what happens. I mean, into our expression. From here, for dy, we got u minus k over 2 du. And then that is divided by u. So it's kind of like this, right? We can put the little u here, and that's going to be dx. But don't worry about that because that's super easy. And now you can just write it as x plus c, c being another constant, right? So now we can go ahead and try to integrate this. How do you integrate u minus k over 2u du? I can separate it. I can write it as 1/2 because u over 2u is 1/2 minus k over 2 times 1 over u, and the whole thing is du, and that's equal to x plus c. Awesome. Now we can go ahead and integrate 1/2. That's going to be 1/2 of u, and this is constant k over 2. The integral of 1 over u is just going to be ln u. I ignore the absolute value, and this is going to be x plus c. So here's a challenge. We have to back substitute. What is u? U is equal to 2 times the square root of y plus k. So let's go ahead and back substitute. So we're going to get the following. Replace u with 2 times the square root of y plus k minus k over 2 ln u, which is 2 times the square root of y plus k, and that is equal to x plus c. And if you want to solve for y, then you have to use a special type of function, which is Lambert's W function, but that's going to be super complicated. Let's go ahead and take a look at Wolfram Alpha and compare our results, right? This should be the answer, and Wolfram Alpha gives us the following. With the Lambert's W function with lots of constants and quite complicated, isn't it? But that's what it is. Again, this is the harder case. If k is equal to 0, we got a much simpler solution, which was x squared plus 2xc plus c squared. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.